Hello and welcome to day 13 of our Cloud Run series. Today we are going to look at Cloud Run jobs and how useful they are. Now, ideally, you would want to use Cloud Run jobs for batch processing or data analytics and machine workloads. Now, they differ from your normal Cloud Run service because your normal Cloud Run service listens on a port, it waits for requests, and then it also scales based on the traffic. So if you have 10 users visiting your service, then based on the concurrency you have set up for your application, it will go ahead to scale based on the traffic coming into your application. That is how Cloud Run services work. There might be some situations where you have a certain number of processes that you need to perform. This can be data analytics workload, this can be image processing workload, and you do not exactly want your service to sit there and listen on the port for some kind of an event. So this is the situation where you want to maybe process batch information or information coming from your IoT devices. You want to run some reports, and these are not activities or actions that you would want your application to sit there and wait for it to happen. You only want your application to perform that action once a certain event happens. So let's just say once new data is added to your database, to your data analytics warehouse, right? Or once a new file is uploaded to your cloud storage. Now, there are a few limits to Cloud Run service that sometimes makes it difficult for you to use for such use cases. One of them is it has a maximum timeout of 60 minutes. And so ideally, it's best to use it for quick interactions. So like websites, APIs, and applications like that. Now, on the other hand, if you want to perform some form of processing, when some event happens, you can still in some ways do it on Cloud Run because Cloud Run allows you to use Event Arc. So you can still configure your Cloud Run service with Event Arc, add a certain trigger for some kind of an event or Event Arc event or cloud storage or Firestore event, and then you can trigger some kind of a function that performs an operation for you. So this works well, but in situations where you just don't want the service to be listening on some port for some kind of activity because you just want that particular thing to run when a certain activity happens. Also, when you want to be able to perform the processing through multiple tasks or multiple processes at the same time. So you can imagine a situation where you have, let's just say, about 1,000 reports to create. If you assign that to a single cloud run service, then you would have to probably have some logic that basically processes the tasks one after the other. Also noting that Cloud Run service has a timeout by default of 60 minutes, so you cannot go beyond 60 minutes. So for such use cases, that is when you can reach out to Cloud Run jobs. Right. Now, when you are using Cloud Run jobs, there are two modes of operation I'd like you to think of. One of them is you process the task sequentially. So this can be very useful for situations where you have a single task that you just want to do. Right. So you just receive some task and then you perform it and that's it. So the job just exits. That is the purpose of Cloud Run jobs. So it just receives a task, it performs it, and then it just exits. Now, if you have a situation in this example where we have, pizza being prepared by some kind of a chef, if this chef has to handle 100 pizzas by himself, then you'll be in a situation where, if each pizza takes 10 minutes, then all of the customers have to wait 10 minutes in order for them to get their own pizza. On the other hand, what you can do is that same company or that same room can have over 100 chefs, right? So in that case, each chef can handle a pizza, which would then allow you to deliver the pizzas much more faster. When you are running your Cloud Run jobs in parallel, you do not you do not exceed the cost that you will be paying for if you are using just a single task. What Cloud Run jobs allows you to do is allows you to break down whatever you are doing into different tasks. And so you can have over 100 tasks, and then each task can perform some form of operation. So you can imagine a situation where maybe if I have 100 reports that I want to generate, I can basically, in that same Cloud Run job, I can basically create 10 different tasks, and those 10 different tasks can be performed by different Cloud Run tasks. So I will just show that in just a minute. Now, what I have here is a simple image processing code base. And what we are trying to do is we are just trying to process certain images and basically resize them into 100 by 100, right? Now, what we want to do in this situation is take advantage of Cloud Run tasks because we could have hundreds of images, we could have thousands of images. We do not want to process them one after the other. So we want to find a way to group those images. So if there are, let's say, 100 images, then maybe I can spin up 10 tasks, and each task can then handle 10 of those images, allowing me, instead of wait, if each image takes 1 minute to process, I would have to wait for 100 minutes. But with this method, I only have to wait for 1 minute because all of the tasks will be spin up around the same time. So maybe roughly within 1 to 2 minutes, all of the tasks will be able to run in parallel, and I'll be able to get my results. Now, once you choose to run your Cloud Run jobs with tasks or different or multiple tasks, Cloud Run does give you two environment variables automatically. So one of them is the Cloud Run task index and then the Cloud Run task count. So the task index is basically what is the current task that is running. And then the task count is the total number of tasks. So if we try to create a new job here, just to see that. So we come to deploy a new container. So let us just select our jobs container. So I will go ahead to select my container and then just say select. I'll give it some name. I'll say my simple nodes processing, that is fine. I'll just use US Central 1 for my region. And I am now able to pick the number of tasks that I want to run in this job. So in the situation where it's just a simple process that I want to perform, I can just go with one, right? So that means it's just a single task that I want to perform. But in my situation, I want around four. Let's just say, okay, let's go with three. Let's just go with three different tasks, right? So I want around three different tasks. So this then allows me to basically say, okay, when I run the job, spin up three different tasks. So you can, if you are thinking of maybe Python, then maybe you can think of like threads or maybe different processes. So it's still the same job, but then you have different tasks that are going to be running, right? And they are going to be running at the same time. That means that your service is basically going to run like three times, right? But you kind of are able to break it down with tasks. It's not as if you have to create three different jobs. You just create one job, and then what Google Cloud would do is it would just basically create three tasks which will run the same code. And so in your code, if you are using the tasks and you are handling multiple processing, then you need to make sure that you take advantage of the environment variables that Google Cloud will give you. So each time that a task runs, Google Cloud will basically give you this environment variable, which is that current task, what is the index, and then what is the total number of configured tasks. So let's just try that. So in order for this to be successful, we need to specify our input folder. So this input folder is just what is the directory or what is the cloud storage bucket where our files are found. So that is what we want to get from here. So let's come to our containers. And then let's come to our variables. Let's add the environment variable. So input folder. So I'll visit my bucket and then I'll just get my folder name, just making sure that it starts with JS. Okay, I think I should go into the folder rather and then get the full name of the folder where my images are. Right. So I have that environment variable. You can then determine what is the timeout for each task. So that means that how long should each task be processed. So what is the maximum timeout that you want to configure for each task? For our process, it's just resizing images. I think even a 5 minute or a 2 minute timer might be okay because we are not doing a lot of things. And you can also configure the number of retries per failed task. So if a task fails, how many times do you want it to be retried? In our case, I don't really want a retry. I will just look at the logs and then fix the issue, if anything. So I don't want a retry, but you can configure a certain number of retries for each task if it were to fail. And then you can choose to run as many tasks concurrently as possible. You need to note though some limits around your Cloud Run jobs. Now, each so if you are using tasks, this is in particular what I'm looking at here. If you are using tasks, right, then the sorry, if you are using maximum, if you are using multiple tasks, because no matter what, you need to at least run one task, right? Unless you are using multiple tasks, right? So if you want to run multiple tasks, then you have a maximum of around 10,000, right? So in a single job, you can run a maximum of around 10,000 and the maximum number of retries for each one is around 10. So you need to consider these limits for your service. And also, you should also need to note that you have around 168 hours. So you have around 7 days, meaning your job can continue running for 7 days, right? Unlike a Cloud Run service, which has a maximum timeout of 60 minutes. So you can have your job running for up to 7 days. So those are some of the advantages. And then, of course, some things you need to note so that once you are writing your code for your processing, you do not exceed those limits. For us, we will be staying within the 7 days limit because it should only take around roughly 2 minutes to do this processing. And so we want to say run as many tasks concurrently as possible because we are running only three. So we are within the limit. So it's fine. If you wanted to limit the number of concurrent tasks, you could maybe say, so this is where must be no higher than 20 for selected CPU and memory. Zero is maximum parallelism, right? Because if you are saying zero, then that means that there's no real limit, right? Or you can configure maybe two at a time. So that means that maybe two will be processed at a time. But in our case, we just want to run as many concurrent tasks as possible. So we go ahead to create our job. Now our job is created, right? So once our job is created, we have multiple ways of executing our job. We can execute it through triggers. This basically allows you to be able to define a Google Cloud Scheduler job, a Google Cloud Scheduler, which then allows you to set some frequency. If this is a process that you want to be executed, excuse me, if this is a process that you want to be executed based on some schedule, some unit schedule, then you can go ahead to use a scheduler for this, right? So this would ensure that if it is 9 a.m., then maybe every day at 9 a.m., that particular job processing would run. So this is very useful if you want to run some process based on a certain schedule. We will not do that for our use case, but if you have some process that you want to run based on a certain schedule, maybe you want to export data from your SQL database somewhere else, that is a very valid use case to set up a scheduler to try to trigger your Cloud Run job. In our case, we just want to execute the job. So I'm just going to go ahead and then click on execute. So this is just going to start a new execution. It might take a few seconds before you start to see some updates, but once you come under history, you should be able to see all of your executions. And so you can just click here to view the execution details. And you can see the overview right at the top here. So you can just wait for just a bit to see how your processing happens or your processing goes. I think I made an error, but let's just wait for this to complete and let's see. So I have a service account that I have given access to. Let me just cancel this. Let me just cancel. I don't want the process to continue. Um, yeah, so this is what I'm saying. When you are creating your services, always make sure to create a service account with the permissions that you need. So I have basically created this service account, which has the permissions to access cloud storage. And so that is what I will use. I forgot to do that. And then I'll go ahead to execute once more. So it takes roughly a few seconds for the execution process to complete. So what I will do is I will just go over this once more. So what I'm doing is I am getting the task index and then I'm also looking for the task count. So these environment variables that will be set by Google Cloud automatically. So whether you are running a single task or multiple tasks, you can still access these environment variables. In our case, we need it for the multiple tasks because we do not want to process an image multiple times. What we have right now is we set up 3 tasks to run. So that means when we execute our job, we will have 3 tasks of our job running. And if we do not do any configuration, then what this will mean is that you will then have multiple runs of the same image. So that means that an image can be the thumbnail for an image or the resizing of an image can be run multiple times. So we want to take advantage of this environment variable, which is like the task index and then also the task count to be able to separate out our processing, right? So I will just jump to that bit of the code base right here. Yeah, so this is where we are trying to determine a chunk based on the task count. So we are trying to say that based on the total number of tasks, we want to divide that by the total task count, which in our case is like 3. So if we have 10 images, then that will be 10 divided by 3, but we want to round it up, right? So that will be around, the chunk size will be around like 4. Right. So during the first processing, we want to find where should we start? Where should we start processing our images? Let's say we have about 10 images. Where should we start processing it? Right. So we will start from the size of the chunk. So at the moment, we will start from 4. So on the first task, when the first task is running, the task index will be 0 because it starts from 0, 1, 2, 3. So it's gonna be the size at the moment, the chunk size at the moment is 4. So 4 times 0. Right. So this is where should it start? So it should start from the very beginning, right? So this is for the first job that runs or for the first task that runs. And then we want to look at where should it end. So this would then be where it starts, which in this case will be 0 for the first job or for the first task because the chunk start is what? 0. This is 0. So 4 times 0 is 0. So we will start from 0 and then we'll go all the way 0 plus the chunk size, and the size is 4. So 0 plus 4. So 0 plus 4 and 10, which is the maximum, which is the minimum. So we will pick 4, right? So that means that we will look at the images. So after we pick out the images, we will start from 0 and then we will end at 4. So that will be like 0, 1, 2, 3, right? So we are only going to process 4 items on the first run, right? So on the first one, we're only going to process 4 items. If we look at the second task that is going to run, for the second task, still the same thing, the chunk size will be 4. And then you look at where it's going to start. So you look at 4 times what is the index? That is going to be what? 1. So 4 times 1, which then gives us what? 4. And then we want the minimum of the chunk starts. So the chunk start is 4 plus what is the size? 4. So 4 plus 4 giving us 8. So 8 and then 10, what is the minimum? We get 8. So That means that on the first run here, the assigned images started from what 0 to what 4. On the second run, we are now starting from what 4 to 8. Right. So the first one will be like 0, 1, 2, 3, and the second one will be like from the 4, right? And then to go all the way to like 7, right? So that would be like the second one. And if you come to the third run, because we are having three tasks, if we come to the third run, still this remains the same. The index would then be what? 2. So we will have 2 times 4, which will then give us what? 8, right? So we'll get here, what we'll get here is the chunk start, which is 8 plus 4. Sorry, 8 plus the chunk size, which is 4. So this will give us like 12 and 10. What is the maximum? So we'll get around 10. Right. And so this would then be from the chunk start to the chunk end would then be 8 to 10. Right. So in this way, we are able to break down the processing. So instead of doing every image once at a time, we have given it to three different tasks, and each task is going to process a certain portion of the images. So one of them is going to process 0 to 4, the other one is going to process 4 to 8, and then the last one is going to process 8 to 9. So we are able to break down the processing of our images and the processing of our tasks. So let us come back to the console. Now we can see that we have three different tasks, and then you can see the index. So you have 0, 1, and then 2. So if you look at the logs, you should then be able to see that, okay, we found 10 images. So 10 images were inside the folder. So we started from 0 to 4, and then we basically processed all those 4 images. Then you come to the second task. We have also 10 images. Then from the index of 4 to 8, and then we processed also 4 images. Now you come to the last one that is going to be like 8 to 10. So we are looking at around just 2 images left. So with this method, we are making sure that, it's not necessary that each task process the same number of items, but it's just necessary that we need to complete all of the number of items. So even if it is just one item left, then the remaining task should ensure that it completes it. Right, so you have 8 and 10, so we only have 2 images for this task, and now we've processed those images. So if I were to maybe look at the artist image right here, let's just say download, this should open a URL for me. So this is the artist image, and then if I were to refresh, I should see a new folder created. So if I go into the new folder, I should now see the same artist image. So I will just go to click on this URL, and I can now see that artist image resize 100 by 100. Right, so this is the original one, and then this is the resized 100 by 100. So you can see all of the 10 images have been resized, and they have been put into a folder that represent like today's date and then the hour. So this is an example of processing items in batches. So when you are using your Cloud Run jobs, you can either use a single task, or you can decide to use multiple tasks. If you are using multiple tasks, then you need to just make sure that you have some kind of a logic like this to ensure that your tasks are not run more than once. So that means that if I'm processing images or I'm processing documents, I do not process one document multiple times. If I was processing all of the images inside this function, that means I'm using a single task, then there will be no need for me to worry about the task index and all of that. Right. If anything, if I have, let's say, retries for failed tasks, then perhaps what I would look at is making sure that when the task fails, I have some process in place to ensure that maybe those tasks that succeeded are recorded, so that I do not repeat the same process for the ones that succeeded. Because if you have 10 items and then let's say 8 of them succeeded but only 2 failed, the next time you retry the job, if you go ahead to do all the 8 once more, then that would not be efficient, right? So you can maybe track those 8 to mark them as completed. And then next time you run, you just check to see whether the 2 remaining have been completed, and then you run those 2, right? So That is how you can run your jobs. But as you can see, if I break it down into tasks, it becomes much more easier for me to manage because now I only have to think about the first four in this one that failed, in this task that failed. I only need to think about the next four in this task that fails, and I also only need to think about the next two in this task that failed. Compared to if I were to use a single task, meaning that I now have to look at the logs for, information about all hundreds or thousands of my batch processes, and I have to now look at them one after the other, right? But if I break them down into tasks, then I can look at the status of specific tasks and those tasks that failed, and then just fix the issue with those specific tasks, right? So this is how you can use Cloud Run jobs. If you have a service or something that just needs to respond to events like website APIs, you can simply just do it on Cloud Run services. But if you have some process that should be done, maybe it needs much more longer time to complete. It is not a process that waits for some user to call, but it is a process that needs to run for a longer time, then you can think of using Cloud Run jobs. So this can be if you want to do some batch processing workloads, you want to do some database exports. You can also use your triggers to ensure that you can use Cloud Scheduler to trigger your service based on a certain time frequency or a certain unit time frequency. So maybe every minute you want to run your job or every day you want to run your job, you can use something like this for that. Another situation is maybe you want to run your job when some event arc trigger happens. So that means that you want to be able to run your job when, let's just say, there's a cloud storage event, there's a Firestore event, there's a PubSub event. Now, you are not able to directly link event arc triggers to your jobs. At the moment, it's not possible just yet. Maybe Google Cloud will change it later, but you are not able to directly trigger your jobs based on an event arc event. So what you can do instead is you can use Google Cloud Workflow. So you can use the Google Cloud Workflow, and then when the event happens, you use that workflow to call the job. Right. So that is how you can go about it. If you still want to use an event tag trigger, workflows work with event tag triggers like cloud storage. And so you can add that event tag trigger. You can configure that event tag trigger in your workflow. And then once that workflow is run, you will then call the job, and then the job can perform the process. So that is how you can handle event tag triggers. I will share the source repo in the description of the video so you can be able to check it out. But thank you for joining. Bye.